Now we're going to look at linear functions and models. A linear model, if a quantity experiences a constant rate of change, then it can be modeled by a linear function in the form f of x equals mx plus b. Or remember, the slope with a linear equation is a constant rate of change, and the b is the initial value, or your y-intercept. Now, first thing we're going to do is we're going to graph. So, given a linear equation to graph, also remember that y and f of x are the same. Solve the equation for y if it's not already. You've got to get it in y equals mx plus b form. Step 2, indicate for yourself what the slope is. This needs to be in fractional form. If it's a whole number, put it over 1. And also the y-intercept. Remember, if x is 0, then that makes this term 0, and all you have left is your constant. So that's your y-intercept. So now here we start the graphing. First you're going to graph the y-intercept, and it has to be on the y-axis. That's why it's called the y-intercept. From the prior point, now use the slope to find another point. So once we graph this one, we're going to start here, and we're going to find another point using your slope. The number in the numerator is your y movement, up or down, and the number in the denominator is your x movement, normally to the right, especially if you move any negative up into the numerator. And then you connect your points with a straight edge. This is one of the quickest ways to graph a linear function. Of course, I've got some examples. Of course. Alright, now I'm going to graph y equals negative 2/3 x plus 5. It's already in y equals mx plus b form. So let's indicate slope and my y-intercept. I happen to have a point hanging around here, so I'm going to put this point on 0, 5. So I've got 1, 2, 3, 4, 5. Let me get it as close as I can. Oh, okay. Now we're going to use, from this point, we're going to use our slope. My y movement will be down 2, my x movement will be to my right 3. So let me get my point again. So down 1, 2, and to my right 1, 2, 3. That's not bad. See how quick it is? And now I'm ready to connect those, and this will be the hard part for me, because I'm going to try and use this. Of course, it's not cooperating. Alright, let me change it a little bit because I got to get it through. And let me move it down. Not bad. So there's the graph of that particular straight line. Now if I get my calculator, another nice thing, if I have this solve for y, I can graph it. So parentheses, negative 2 divided by 3, x plus 5, and I'm going to do ask it to graph, and it should look, now if you'll notice mine's square, this one is more rectangular. Let me see if I can square it up. Let me do number 5. That looks much better. Yeah, I like that. So it it coordinates with what I've got. Well, let's try another one. I've got y equals 4x minus 3. Again, it's in the correct form. So indicate your slope in fractional form and your y-intercept. So let me get my point that's hanging around. It's not cooperating. So I've got to go down to 3, negative 3. That's not bad. And now with my slope movement, I go up 4, right 1. So from the point, up 1, 2, 3, 4, and right 1. Okay, so now I've got my points. So now let me go get my straight line. And let's see how I can connect these. Let me shift it down a little bit. There. That's not bad at all. Of course, I've got some more. I've got these all covered up. So I need you to graph using the slope-intercept form. So go and graph this, pause me, and go graph this and see if you come up with what I did. I'm going to go ahead with it, so you need to pause. My slope is -3/4. My y-intercept is 0.6. So I plotted the point 0.6, and from there I went down 1, 2, 3, and to my right 1, 2, 3, 4, and I connected. This one is a little bit more ornery than the other one because I've got to solve for y. So first thing I'm going to do is subtract my 9x. So let's see if I did that here. Okay, so I subtracted my 9x. Now I need to divide by -4. Be careful if you divide by -4. A -9 over -4 is not a -9 over -4. It's a positive 9/4. And then 24 divided by -4 would give me a -6. So here's my slope. There's my y-intercept. So I'm going to plot that point and move using my slope movement. So let's see I did. If I did 1, 2, 3, 4, 5. There's my -6. So let's see if from this point if I go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 4. 1, 2, 3, 4. And I connected. Okay. 2 more. This is in y equals mx plus b form. And just because if they use functional notation, remember p of x, f of x, g of x, that's y. Whoa, it jumped on me. So here's my slope, my y-intercept. Don't know why it's doing that. Anyway, put my point 1, 2, 3, 4, 5, 6 down 1 over 1. Okay? Now this one. It's y equals -2. Now we've seen something like this in the past. Remember, for my x to not be there, that means my slope is 0. So 0 over 1, so my y-intercept is 0, -2. Now let's see about this one. I plotted my point, and if I go 0 up or down, that means I don't go anywhere, but I go right 1. If you connect, notice with a slope of 0, I have a horizontal line. Okay? So that's it for this particular part. See you later, or talk to you later. Thank you.